Hello, Dumelang, Sanbonani, Molueni, and a warm welcome to the Maths Genius video tutorial series brought to you by SABC Education. In these tutorials, we help you unleash the mathematical genius in you by showing you key mathematical concepts and how you can master them for success like a true genius.
Today we're going to be looking at probability and seeing how we test for independence. So before we start, let's just give you the multiplication rule. So the multiplication rule states that if A and B are independent events, then the probability of their intersection is equal to the product of their individual probabilities. Meaning that probability of A intersection B is equal to probability of A times probability of B. So this is the litmus test for independence. If anyone was to ask you, are these, in a probability question to say, are these two events equal? Independent, sorry. You have to now go out and check out what the value of the intersection is and the individual probabilities of each of the events and their product. If it's equal, if the left-hand side is equal to the right-hand side, then you know that the two events are equal. So let's just do a quick example, right? So, is the purchase of a TV set dependent on whether there was an advert seen? So we're testing the relationship to say, is the purchasing of a TV dependent or independent of whether you saw an advert or not? So I'll just do a quick table where you have saw advert, saw ad, did not see ad. Okay? Those are your two columns, and then you have a total here, marginal total, right? And then this side you have purchased TV, did not purchase TV. So these are your two options on the horizontal, on the rows. Then you've got a total here, marginal totals as well. So like that. Okay, so we've got our possible responses. Now, let's assume that this was 10, this was 12, so it means that the total of those who saw the advert would be 22. And then those who did not see, let's say 5, 7, so this would be 12. So the number of people who bought a TV would be 15, and the number of people who did not buy a TV would be 19. So our total, our grand total in this case would be 34, right? 22 plus 12 will give you 34. 15 plus 19 will also give you 34. Now, let's now test the independence of this statement, where we're saying, is the purchase of a TV set dependent on whether someone saw the TV, the ad or not? So, what is the probability that someone purchased and saw the TV, right? So the advert. So the advert is this column here, the first column, and purchased TV is the first row. So where they meet, that's the intersection. So you're saying out of the 34 people, 10 out of 34 did see the advert and also purchased. So it means the probability of A intersection B is equal to 10 out of 34. So that's your left-hand side. Now let's do the right-hand side. what is the probability that someone saw the advert, right? The probability that someone saw the advert. So here, there are no conditions. It's just, did you see the advert? If you did, then it will be 22 out of 34. 22 out of 34. Then, what is the probability that someone purchased a TV set? So purchase is along this row, and it will be 15 out of 34. So PB is equal to 15 out of 34. So, for us now to prove whether they are independent or not, we have to say if left-hand side is equal to right-hand side, then the two events are independent. Right? So now, this is your left-hand side, and the product of these two will give you the right-hand side. So now, it is now your homework to go and see, multiply these two and compare with 10 out of 34 and see if they're going to be equal. If equal, then you know you've actually proven independence. If not, then the two are dependent. Thank you very much.
Thank you for taking the time to watch this video. Unleash your mathematical genius today. If you have any maths questions, you can post them for free on www.mathsgenius.co.za or email them to info@mathsgenius.co.za.